Lastly, we're going to find all x values for which f of x's function below will have a horizontal tangent line. Well, we talked about that on the graphical analysis. Horizontal tangent line is when the slope is equal to 0. All right, or remember that the slope is found from our derivative when the derivative is equal to 0. All right, those are the line of reasoning, the line of steps I would take in my head. So this isn't the derivative, this is f. So what we're going to do first is we're going to find the derivative using the power rule. Bring the 3 down, subtract 1. Bring the 2 down, subtract 1. There is that 1 down, you can think about that, but remember that's a linear function, so we're just going to make that negative 24. So there's our f prime. All right, and we want that derivative to be equal to 0. We're not plugging in 0. We don't want to know the slope at an x value of 0. We want to know when the slope will be equal to 0. So that's why we're setting it equal to 0 here. Now, in this case, we're working backwards to find when our slope will be 0. So we're going to solve for our x values. I got a quadratic. I can factor out a 3 as a GCF. That's just always a nice check. And then I'm going to look to see what two things will multiply to give us negative 12. Oh, 24 divided by 3 is not 12. Come on, Krish. 24 divided by 3 is 8. And now when I multiply two things to give me 8, let's see. What two things will give me 8? I might need to do that work off to the side. I got 1 and 8. I got 2 and 4. That's it. Let's see. I need them to give me 2. Well, that's going to be a combination of 2 and 4. The 4 needs to be positive. The 2 needs to be negative. That'll give me a negative 8 and a positive 2. So here's my factored form. So now I just need to figure out, all right, which values would make this 0? Well, remember that's just going to be negative 4 inside there, and that's going to be a positive 2 there. So let's go take a look. I got a positive or negative 4, positive 2, done.